Welcome to Lesson 1-4, Comparing and Ordering Decimals.
My family wants to start paying more attention to the kinds of food we eat. We're going to look more closely at the nutrition information found on the boxes of cereal, crackers, granola bars, and so on.
That is a great idea, Hank. I think my family should do the same thing. Do you want to go to the grocery store and take a look at the labels on a few different types of food?
Sure, let's go. We should first check how much fat is in each serving. Then we should choose the item with the least amount of fat per serving. The cereal bars only have 3.1 grams of fat per serving.
The wheat crackers have 3.72 grams of fat per serving.
The rice cakes have 0.33 grams of fat per serving.
And the bran cereal has 0.5 grams of fat per serving.
Now we have to compare each of these numbers to decide which is the smallest and which is the largest. Then we will know which item has the least amount of fat per serving.
Before we can do that, we have to make sure we know how to compare and order decimal numbers.
Before we get going, let's review the greater than, less than symbol. We will use this symbol when we are comparing decimal numbers. The symbol has a larger end and a smaller end. When you are comparing two numbers to determine which one is greater, the larger end of the symbol faces the larger number. The smaller end of the symbol faces the smaller number. If the numbers were on the opposite sides, then the symbol would turn the opposite way, like this. The larger end of the symbol faces the larger number, and the smaller end of the symbol faces the smaller number.
We'll start by comparing decimal numbers that have a digit as far as the tens place. When we compare numbers to figure out which one is greater, we always start with the digits having the greatest place value and move to the right from there. When we compare these two numbers, we start with the digits having the greatest place value. This means we start with the ones or whole numbers. Because 6 is greater than 5, we know that 6.2 is greater than 5.2. We don't have to look any further than the ones place. Now you can answer some questions using the greater than, less than symbol. Drag the correct symbol between the numbers to make the math sentence true.
Correct. To compare two numbers, we start with the greatest place value. Because 11 is greater than 1, 11.2 is greater than 1.4.
Drag the correct symbol between the numbers to make the math sentence true.
Correct. To compare two numbers, we start with the greatest place value. Because 1 is greater than 0, 1.7 is greater than 0.7.
Before we continue, let's explain what a 100 grid is. We will be using this grid to compare decimal numbers. The grid is divided into 100 squares. Each of these squares represents 1 out of 100, or 1/100th. The grid can also be divided into 10 strips of 10 squares. Each of these strips represents 1 out of 10, or 1/10. Let's look at some more numbers. We'll compare 0.8 and 0.3. We can make it easier by using 100 grids to show the numbers. We'll first fill in the 100 grid to represent the number 0.8. The number 0.8 means 8 tenths, so we can fill in 8 of the 10 strips to show the number. We'll do the same for the second number. When we slide one grid over the other, we can see that 0.8 is greater than 0.3. You can use a diagram to help you, as we have just done, or you can compare the numbers by looking at the digits. We'll compare the numbers starting from the left with the greatest place value. Because both numbers have a 0 in the ones place, we don't yet know which number is greater. We'll have to move on to the next place value. When we compare the tenths in both numbers, we see that the first number has 3 tenths, and the second number has 8 tenths. We know that 0.8 is greater than 0.3. Now you can answer some questions using the greater than, less than symbol. Drag the correct symbol between the numbers to make the math sentence true.
Correct. To compare two numbers, we start with the greatest place value. Because both numbers have a 0 in the ones place, we must compare the tenths. 9 is greater than 1, therefore 0.9 is greater than 0.1.
Drag the correct symbol between the numbers to make the math sentence true.
Correct. To compare two numbers, we start with the greatest place value. Because both numbers have a 1 in the ones place, we must compare the tenths. 8 is greater than 7, therefore 1 and 8 tenths is greater than 1 and 7 tenths.
We can also compare decimal numbers that have digits as far as the hundredths place. Let's compare the numbers 0.29 and 0.65. Once again, we'll show these numbers on 100 grids. The first number, 0.29, is also expressed as 29 hundredths. That means we can fill in 29 of the 100 squares on the grid to show this number. The second number, 0.65, is also expressed as 65 hundredths. That means we can fill in 65 of the 100 squares on the grid to show this number. When we slide one grid over the other, we can see that 0.29 is less than 0.65. Let's compare these numbers by looking just at the digits. We'll compare the numbers starting from the left with the greatest place value. Because both numbers have a 0 in the ones place, we don't yet know which number is greater. We have to move on to the next place value. When we compare the tenths in both numbers, we see that the first number has 6 tenths, and the second number has only 2 tenths. That means that this is as far as we have to go, because 6 is greater than 2. We know that 0.65 is greater than 0.29. If 0.65 is greater than 0.29, then 0.29 must be less than 0.65. Now you can answer some questions using the greater than, less than symbol. Drag the correct symbol between the numbers to make the math sentence true.
Correct. To compare two numbers, we start with the greatest place value. Because both numbers have 0 in the ones place and 5 in the tenths place, we must compare hundredths. 6 is greater than 5, therefore 56 hundredths is greater than 55 hundredths.
Drag the correct symbol between the numbers to make the math sentence true.
Correct. To compare two numbers, we start with the greatest place value. Because both numbers have a 1 in the ones place, we must compare the tenths. 7 is greater than 0, therefore 71 hundredths is greater than 7 hundredths.
We have compared decimal numbers that have digits as far as the tenths place and as far as the hundredths place. We can also compare decimal numbers where one number has digits as far as the tenths place and one number that has digits as far as the hundredths place. Let's compare 0.02, which has a digit as far as the hundredths place, with 0.2, which has a digit as far as the tenths place. Once again, we'll show these numbers on 100 grids. The first number, 0.02, is also expressed as 2 hundredths. This means we can fill in 2 of the 100 squares on the grid to show this number. 0.2 is also expressed as 2 tenths. That means we can fill in 2 of the 10 strips on the grid to show this number. As you can see, 2 strips of 10 squares make a total of 20 squares. Another way of looking at the second number is to add a 0 in the hundredths spot as a placeholder. This way we are comparing hundredths with hundredths. 2 strips are equal to 20 squares on a grid. Whether we call it 2 tenths or 20 hundredths, it is the same amount. Now we can slide one grid over the other to compare the number of colored squares. We can see that 0.02 is less than 0.20. Let's compare these numbers by looking at just the digits. Starting from the left as always, we can see that we'll have to move on because both numbers start with 0. This does not yet tell us which one is greater. Now we're getting somewhere. When we compare the tenths in both numbers, we see that the first number has 0 tenths. And the second number has 2 tenths. Because 2 is greater than 0, we know that 0.20 is greater than 0.02. If 0.20 is greater than 0.02, then 0.02 must be less than 0.20. Now you can answer some questions using the greater than, less than symbol. For an added twist, you may choose to use the equal sign as an answer. Drag the correct symbol between the numbers to make the math sentence true.
All right, if I'd be looking at this, we have 3 tenths and we have 8 hundredths. Remember, you can always add that extra 0 here. That would be 0.30, and this is 0.08.
Drag the correct symbol between the numbers to make the math.
0.70, 0.7. Remember, there's always hidden zeros behind here, so this one would be 0.70 as well. Therefore, they would be equal.
Sentence true.
Notice they line up the decimals always to compare them.
Now that we have compared several pairs of decimal numbers, we are ready to put a group of decimal numbers in correct order on a number line. An excellent way to do that is to use benchmark numbers. A benchmark number is a number that is familiar and easily recognized. For example, on this number line, we label the first point as 0, the second point as 0.5, and the last point as 1. These numbers can all be called benchmark numbers. Now that we have established our benchmark numbers, we can look at other numbers to see how they compare to the benchmarks. Let's try placing a few numbers on the number line. We know that 0.43 is slightly less than 0.5, so we can place it on the number line next to the 0.5. Remember, you can add 0 as a placeholder if it helps you to compare the numbers. Now we can place the next number. 0.99 is very close to 1, so it can go right next to the 1 on the number line. Our next number, 0.2, is not quite half of 0.5, so we can place it on the number line just about halfway between the 0 and the 0.5. 0.8 is more than 0.5 and less than 1. It is closer to 0.99 than it is to 0.5, so we can put it toward that end of the number line. And finally, we are left with 0.01, which is a very small number. It is close to 0, so that is where we can put it on the number line. We have now put these numbers in order from least to greatest by using a number line with benchmark. It's your turn to put a group of decimal numbers in order from least to greatest on a number line. Drag and drop the decimal numbers onto the number line in order from least to greatest. When you're ready,
1.67. It's 1 point something, so it's bigger than 1. Would it go before 1.5 or after 1.5? I would say after, because remember this is 1.50. So 1.50, 1.67. Let's take a next one that goes after 1. This would be 1.1 or 1.10, and then 1.50, 1.67, and the number 2. I've got 3 left. One of them goes after 0.5. Remember, this is like 0.50. Which one will go after 50? 0.72. And our last 2, I have the number 3 and the number 16. 3 comes before 16.
click the check button. Drag and drop the decimal numbers onto the number line in order from least to greatest. When you're ready,
all right, let's take a look again with that. We have 2 numbers that are smaller or less than 1. Here's my 1 benchmark. I have 2 that are smaller. Which 2 would it be? It would be this one, 0.9, 0.09. 0.9 really means 0.90. 0.90 is closer to 1. It's above or greater than 0.50. 9 is really close to 0. I've got a couple numbers that are between 1 and 1.5, 1.5, and one more between 1 and 2. Okay, which number is greater? Let's look for this one. Which one is greater than 1.5? 1.50. 1.99 is greater than 1.50. That leaves these two, 1.01, 1.2. Remember, this could be 0.20. So 1 in 100th or 1 in 20 hundredths.
Now we are ready to decide which food has the most fat per serving and which one has the least fat per serving. Let's start by finding the one with the most fat, and then which of these foods has the greatest amount of fat per serving? Drag and drop your choice into the top position on the list.
All right, the decimals are lined up. The greatest looks like the wheat crackers, 1.72.
Which of these foods has the second greatest amount of fat per serving? Drag and drop your choice into the second position on the list.
All right, looks like 3.1 or 3.10.
Which of these foods has the third greatest amount of fat per serving? Drag and drop your choice into the third position on the list.
Remember, this is 0.33 and this is 0.5, which would be 0.50.
This leaves the bran cereal with the least amount of fat per serving. Down. We have now put the food in order from the most fat per serving to the least fat per serving. This will help our families to make healthy food choices.
Yes, next time we go grocery shopping, we will be able to help our families make those choices because we know how to compare and order decimals.
In this episode, you have learned to compare decimal numbers by starting with the digit having the greatest place value, whole numbers, and to move on to the tenths and hundredths if necessary. In our book, we will also be doing thousandths. To use a number line with benchmark numbers to put decimal numbers in order from least to greatest. Please take out your notebook for your notes tonight. Please write 1-4 at the top. When comparing and ordering decimals, line up the decimals. That is the only note you need to take. Remember that you need to always line up the decimals in order to compare. At the very bottom of your page, make sure you write down any questions you have, and you can ask us tomorrow. Have a great night.